So I'm going to try a different software for the videos. So it looks a little bit different, but we'll try it out and see how it works. So day 21 homework. I know a lot of you guys said you were a little bit confused. The big key idea and takeaway is always do outside first and then move to the inside when you're doing these complicated derivatives. So on number one, the very outside would be the cubed, right? That would be our outside. And so what we're going to do is we're just going to kind of think of, what would box cubed, what would be the derivative of box cubed or x cubed, right? The derivative of x cubed is 3x squared. The derivative of box cubed is 3 box squared times the derivative of the box. That's our chain rule. So that portion is the chain rule. So here, that box is a quotient. So what's going to kind of happen is we're going to do chain rule. But then when we do the chain rule, that box is going to have us then do the quotient rule. So that's why these get a little more complicated. So with number one, as we jump into that, right, 3 box squared. Our box, we're just going to rewrite x plus 5 over x squared plus 2. And then all of that's going to be squared. Now times the derivative of the box. So the derivative of this box, right, we're going to kind of like cross out the 3. We're not worrying about it anymore. And this would just be a quotient rule problem. Low, d high, minus high, d low, all over low squared. Okay, and this is a perfectly fine answer. If you had that as your answer, full credit. Now we can simplify it. So I'm going to write this, 3 times x plus 5 over x squared plus 2, all squared, and then times, this will be x squared plus 2. Now this negative distributes, but also we're going to also multiply everything by 2x. So this is going to be minus 2x squared minus 10x. They both get a negative symbol. All divided by x squared plus 2 squared. And we can look at our like terms. So I like to underline, x squared terms once, x terms twice, numbered terms 3 times. And then what we'll end up with is 3 times x plus 5 over x squared plus 2 squared times negative x squared minus 10x plus 2. And this would be full credit. A lot of you guys might have stopped here. This is totally full credit. Now, if we want to simplify a little bit further, we can factor out a negative. So we get negative x squared plus 10x minus 2. And then we can also kind of what we can do is we could, this again would be a perfect answer. But what we can also do is we can take that squared and we can distribute the squared to both the numerator and the denominator if we want to multiply across. Right, so we took the squared and it went to both the numerator and the denominator. And so I can write this as negative 3 parentheses x plus 5 squared times x squared plus 10x minus 2, right? I took that negative sign and I moved it to the front. All divided by, now x squared plus 2 squared is going to be to the 4th power. So this is kind of the most simplified version, right? Nothing else factors, but that's our most simplified version. So any of these answers, really full credit, and you're on the right track. So next one, very similar, is we are going to have, start off with that outside. So the outside is going to be the square root. So this is going to be the square root of box. So if we had f of x as our square root of box, right? Just like f prime of x is 1 over 2 squared of x, f prime is going to be 1 over 2 squared of box times the derivative of the box. And that's going to be our chain rule portion. So Here, we're going to say f prime of x, very similar to the last question, equals 1 over 2 square root of 2x plus 3 divided by x minus 2 times, now the derivative again is going to be a quotient. So low d high minus high d low all over low squared. And if you got this far, that's great. You're on the right track. And now it's just practicing how we simplify. So our next step in this side, what I'm going to do is I'm going to make this square root of 2x plus 3 divided by the square root of x minus 2. And then times, and then on this side we'll distribute. So 2x minus 4, distribute our negative, minus 2x minus 3, all divided by x minus 2 squared. And then what we can do is, I don't like to have the fraction inside of the fraction, so we'll do times square root of x minus 2 and times square root of x minus 2. Now, we're only multiplying essentially like on that left side, right? Because these are being multiplied, so we don't need to worry about what's inside the parentheses, right? Because it kind of counts as the same term since it's being multiplied. So these will cancel out, and that'll give us the square root of x minus 2 times, now 2x minus 4, so the 2x and the 2x cancel, negative 2x, and negative 4 minus 3 would be negative 7, all divided by 2, square root of 2x plus 3, I'm just multiplying across, times x minus 2 squared. Okay, and this is a perfectly fine answer. We can leave our answer like this, maybe move the negative 7 to the front. So negative 7 square root of x minus 2 over 2 square root of 2x plus 3 times x minus 2 squared. That's, full credit. And that's probably how I would write it. But if you do notice, hey, wait, I have an x minus 2 term on the numerator and an x minus 2 term in the denominator. Can we cancel those? We sort of can, right? You're going to write this as x minus 2 to the 1/2 power over 2 square root of 2x minus 3, or plus 3, times x minus 2 to the 2nd power. So what we can do is we can cancel out a 1/2 power. So what happens is when we cancel out a 1/2 power, 2 is 4 over 2. 4 over 2 take away a 1/2 becomes 3/2. And so we end up with negative 7 divided by 2 square root of 2x plus 3 times x minus 2 to the 3/2. And that's kind of an even better answer, right? And we can leave it like that. If you want to put the x minus 2 into a radical form, like the square root of x minus 2 cubed, you could, but I left it like that. Okay, number 3, almost identical to the last one, except instead of having a quotient inside, we just have a nice polynomial. So it's even easier than the last one, actually. So h prime of x, same kind of concept. We're going to do 1 over 2 square root of our box. And then times, now we need to make sure, this is very important, this needs to go into parentheses. When we do chain rule, it needs to go in parentheses. So 2x minus 3. If you don't have this parentheses, you're going to lose points on the AP exam. Because if you don't have the parentheses, it's only being multiplied to the 2x. And then it's like all of that and then minus 3. But we don't want to do that. We want to multiply by the entire 2x minus 3, so we need the parentheses. Now what you can do is you can bring this to the numerator, right? Kind of like lollipop it, multiply across. And we end up with 2x minus 3 divided by 2 square root of x squared minus 3x plus 1. This should have been a very easy question. Okay, our next one. This is a cube root, so we can't do the shortcut on this, right? We can't do the shortcut. We have to first rewrite this as 9x squared plus 4 all to the 1/3 power, right? You can only do the shortcut for radicals, square roots, not for cube roots. So in this case, g prime of x would be 1/3. Now we have a box here. So 1/3 times our box, 9x squared plus 4, to the negative 2/3 power. We get the negative 2/3 power when we subtract off 1, right? That's just doing power rule. I'm going to kind of get rid of that, and now we're going to do times the derivative of the box. So times 18x. And from here, it's just kind of simplifying. So I'm going to put the 18x into the numerator. Right? You could have also canceled out the 18 with the 3, and that works. Divided by 3, and then I'm going to move the 9x squared plus 4 into the denominator with a 2/3 power. So that's full credit, but even better, cancel that out and make it a 6x. And then if you wanted to put it back into radical form, we also could write as 6x times the cube root of, in parentheses, 9x squared plus 4 squared. Right? The 3, the denominator, goes here into the radical, and the squared stays with it, kind of hugging it. So either one of those two answers, full credit. Okay, moving on. Next, we're going to just find the derivative at a point. So step 1 is going to be to take the derivative. Step 2 is to plug in. Now, before we take the derivative, anytime we have sine squared of theta, what I told you guys is to make sure you write this as sine, in this case it's sine of 2 theta squared. Now, the squared is only going to the sine, it's not going to the 1/4, so make sure we write that correctly. So the 1/4 is just a coefficient, it just basically stays. So we said we're always going to work with the outside and then move in. Now, a 1/4 is a coefficient, so it just kind of stays 1/4 times, right? So the outside here is the 2. So it's kind of like having a box squared. So we're going to bring the 2 down, 1/4 times 2 times our box to the first power, right? We're going to drop the first power, but I'll write it here just to kind of show. Now times the derivative of the box. Now, what's the derivative of sine? Is cosine. But we have sine of 2 theta, not of theta. So this is going to be another, I'm going to cross out the 2 because we already did that. Now we're going to do the derivative of sine. So the derivative of sine is cosine of the next box, which is 2 theta. Now I'm going to cross out the sine, and then times the derivative of 2 theta is 2. Right, and if you want to even add, some people will always just, even though they didn't write it, they'll put a little parentheses around the 2 theta, just to kind of show that it's cosine of 2 theta. If you want to do that, that's great. So 2 times 2 is 4, which cancels out with the 1/4. So this becomes sine of 2 theta times cosine of 2 theta. If you don't have those parentheses, it's fine, but they are nice. So we have sine of 2 theta times cosine of 2 theta. And so now what we're going to do is we are going to multiply, or we're going to plug in. So we're going to say, okay, what is g prime of pi? Right, and we need to do that, we need to kind of know at pi, right, we're at -1, 0 on our unit circle. So sine of 2 pi, actually we're at pi, we're at 2 pi, because the reason we're going to actually be at 2 pi is when we plug in the 2. So at 2 pi, we're at 1, 0. Right, so kind of it's sine of 2 pi, cosine of 2 pi. We'll end up with the same answer though, because the sine of 2 pi is 0 times 1, so we end up with 0. Okay, next one, sine of 2 theta, cosine of 2 theta. So whenever we have 2 x's or 2 thetas next to each other, without adding, we know that that's multiplying, which is product rule. So we're going to do product rule now. Sine of 2 theta and cosine of 2 theta are going to get chained. But remember I said we start off with the outside. In the last question, the outside was the squared. In this question, the outside is sine, cosine. Like there is no real outside. The outside is the product. So we're first going to do the product rule. And a lot of times this happens with product rules. First, we go with product. And then second, as you're doing the product rule, the chain rule kind of comes out. So if there's no outside squared, right, in this case, there's no outside squared. We're just looking at this. There's no outside square root, anything like that. It's just sine of 2 theta basically times cosine of 2 theta. So we're going to do f prime of theta. Now, product rule says take the derivative first. So the derivative of sine is cosine of 2 theta. But then times, because it's not sine of x or sine of theta, it's sine of 2 theta. So quotient rule says to then multiply by the derivative of the inside, so times 2. Then we're going to leave the second term, the cosine of 2 theta, alone. Now we'll do the same the opposite way. So we're going to leave the first one alone. And then times, now the derivative of cosine is negative sine. We're going to leave the box alone, but then times 2. That's the chain rule part. So this gives us 2 cosine of 2 theta times cosine of 2 theta minus I'm going to move the minus and the 2 to the front, minus 2 sine of 2 theta, sine of 2 theta. And on a lot of AP multiple choices, they might write that as like cosine squared 2 theta, right? Or in sine squared 2 theta. You don't have to on this question because it's asking you at pi over 4. So whenever it's saying at a certain term, I never worry about simplifying. I just plug in as quickly as I can. So that's what I'm going to do here. So f prime of pi over 4, that's going to give us 2 cosine. Now 2 times pi over 4 will give us pi over 2 times cosine of pi over 2. And again, if you have that squared, that's awesome. I really like that. But I just chose to plug it in as quickly as I could. So at pi over 2 on our unit circle, that's up here, that's at 0, 1. So the cosines are going to be 0, 2 times 0 times 0, that all goes to 0, minus 2 times 1, so we end up with negative 2. Okay, moving on. So, let's see, should be on number 9. There we are, okay. So on number 9, we have a graph of the function f of x equals square root of 25 minus x squared. That's a half circle, right? And we want to find the values of f of 3 and f prime of 3. So f of 3, we could do either way. We could just use the graph. So we could literally just look on the graph at x equals 3, the y value is 4. And just say f of 3 equals 4 from our graph. You also could have plugged it in. You could have said f of 3 equals the square root of 25 minus 3 squared. 25 minus 9 is 16, and the square root is 16. Now, technically, it's plus or minus 4, but we're just going to say 4 because it's from a function. So I've said this a few times, but basically, if we're doing f of x equals like the square root of 16, we're just going to use the positive side, the positive 4. If I had x squared equals 16, and I square root both sides, we're going to do plus or minus 4. Right? And you can kind of see that because on this case, there is, at negative 3, we also have 4, right? So like this is x equals negative 3, x equals positive 3. Like the x's get the plus or minus, it can still be a function. But for the y values, we don't have anything down here, right? We don't have that bottom of the square root. So technically that's the full circle, but we're missing the bottom case because that wouldn't make it a function. So that's why with functions, we only do the positive case, or if there's a negative in front of the square root, then it would only be the negative case. Whereas with x's, we do both. So just kind of a reminder. Okay, so that was f of 3 was 4, and then they also said find f prime of 3. So f prime of 3, in order to do that, first we have to do f prime of x. So first we're going to do f prime of x. This is similar to what we've been doing. 1 over 2 square root of 25 minus x squared times, chain rule, negative 2x. The negative 2's will cancel. And we end up with negative x divided by square root of 25 minus x squared. Plug in 3. And we get negative 3 divided by the square root of 25 minus 3 squared, which we said was 25 minus 9 was 16. Square root of 16 we said was 4. So our f prime of 3 is negative 3/4. Okay. Find the equation of the tangent line to the graph at x equals 3. So we're going to do x1 was 3. Y1 we already plugged in. We got 4. And m we already plugged in. We got negative 3/4, right? Y1 is the f of 3. M is the f prime of 3. So this is y minus 4 equals negative 3/4 times x minus 3. So what we can do to graph this accurately is to start off with the point 3 comma 4, which I already have plotted, and then use our slope down 3 over 4. So down 3 over 1, 2, 3. 4 is going to be somewhere over here. And going backwards is a little easier. Up 3, up 1, 2, 3, left 1, 2, 3, 4, somewhere over there. So kind of using those points just to help us get our graph. Now, if you have a ruler straight edge, make it a little bit nicer. Okay, always make sure to also put arrows on your graphs. A lot of you guys have not been putting arrows. If a graph keeps going, it needs to have an arrow. Okay, next one, find the equation of the normal line. So normal line, same process, except now x1 is still 3, y1 is still 4. It intersects at that same point, but the m is going to be the perpendicular. So positive 4 over 3. So y minus 4 equals 4/3 x minus 3. We're going to start off at that same point, 3 comma 4. But now we're going to go up 3, up 1, 2, 3, over 1, 2, 3, 4. Or down 3, left 1, 2, 3, 4. And so when we graph this, what should happen is if we had graphed it totally correctly, it should look like a perpendicular line. I didn't use a ruler, so mine doesn't look quite perfectly perpendicular. Oh, and I think it's actually because I didn't go up 4. Right? It's up 4 over 3. I think I did that backwards. So up 1, 2, 3, 4 over 1, 2, 3. Yeah, I had it graphed wrong. Down 4 over 3. So that's where the point should be. That's why mine. And so that's kind of a good check on yourself, is make sure that it actually looks perpendicular. Now it does. So there's our normal line. Okay. At what values of x does the graph h of x, or no longer using that graph up there, have a horizontal tangent? Now when we see horizontal tangent, we're always thinking the slope is 0, right? So we're going to set the f prime of x to 0. Now it just asks for the values of x. If it asks for the points, we'd plug them back in and do like, an x comma y. But here it just wants x, so we only need x. So we're going to take h prime of x. Now, actually, I'm going to draw it over here to give ourselves a little more room. Because if we notice, whenever we have two x's back to back, that's product rule, right? We're always starting with the outside. There is a square root, but even more outside of the square root is being multiplied, right? We're doing like PEMDAS backwards. So h prime of x, the derivative of the first is 1/2 x squared. The derivative of that is half times 2, kind of will cancel. X to the first power. Then we're going to leave the second part alone. Then plus, now we're going to do 1/2 x squared, leave that alone. And the derivative of the square root of 2x plus 1, this is where we're going to do a chain rule. So the outside of that part is the square root times the derivative of the inside is going to be the square root of like the 2x plus 1 part, so times 2. We're going to cancel out those 2's. So this gives us x square root of 2x plus 1 plus, now what I'm going to do is I'm going to move the x squared to the top, and I'm going to move the half, the 2 there, to the bottom. So plus x squared divided by 2 square root of 2x plus 1. Now if you didn't do that, that's okay. If you left it as, half x squared times 1 over square root of 2x plus 1, that's okay. But I like to always kind of move my numerators and my denominators to make it look cleaner. Now, you could keep simplifying. You could lollipop the left side, multiply by 2 squared root of 2x plus 1 over itself. But we don't need to do any of that because we're plugging in, or in this case, we're solving. So we're saying, when did the slope equal to 0? So I'm going to say h prime of x is 0. Right? That's what we're plugging in. We're plugging in the slope as 0. And you could try to get this into one fraction, but I don't like that. Anytime I have fractions what I always do is I just multiply every term by the denominator. So times 2 squared root of 2x plus 1 times 2 squared root of 2x plus 1 and times 2 squared root of 2x plus 1. Right? Each term on the left side and each term on the right side would multiply. Wherever you have a plus, that's like our separator. So here, that cancels out. On the 0 side, we're going to get 0 equals. Now, I'm going to multiply the 2 with the x, and square root of 2x plus 1 times square root of 2x plus 1 becomes square root of 2x plus 1 squared. Right? If we kind of think of it like that. And those cancel. So it turns into parentheses. Make sure you have the parentheses, 2x plus 1. And plus x squared. This is going to give us 0 equals 4x squared plus 2x plus x squared. Okay. And then what that's going to give us, we'll kind of write this up here. That'll give us 0 equals to 5x squared plus 2x. So we can cancel out, or sorry, we can factor out an x. So we get 0 equal to x, or 0 equal to 5x plus 2, right, from each of those two sides. So 0 equals x, that's one answer. Our other answer, subtract 2, divide by 5, is x equals negative 2/5. Next up, we have one of these table questions. I know these are tough right now, but they get easier. And this one's definitely tough because it's this whole combination of chain rule and quotient rule and product rule. But, you know, it's just something that we got to start practicing. So looking at the outside, what's the outside? Is the square root. Then inside, I'm just going to box it for right now, and we'll deal with what it is later. So h prime of x. By the way, how do I know I'm taking the derivative? It asked, is it increasing, or decreasing? So if it ever asks, is it increasing or decreasing? We always connect that with increasing as h prime of x is positive or greater than 0. And decreasing as h prime of x is negative or less than 0. So we need to take the derivative, plug it in, and kind of see what the number looks like. So 1 over 2 square root of our box, f of x times g of x. Now times, so now we got rid of our square root. Now we're going to multiply by the derivative of the inside. Make sure this is in a parentheses. If it's not, you're going to get it marked wrong. So times f of x, sorry, f prime of x, the derivative of the first, times the original second, then plus the original first times the derivative of the second. If you wanted to put each of those in a parentheses, you can. Now what we can do is we can move that up to the numerator if we want to. So we can write this as f prime of x times g of x plus f of x times g prime of x all over 2 square root of f of x times g of x. So now we're going to plug in negative 1. Now, I can rewrite all of that with f prime and negative 1 and whatnot, but I'm going to try to save some time. So f prime of negative 1 is negative 2 times g of negative 1 is 1. Then plus f of 1 is 3 times g prime is 1, all divided by 2 square root of f is 3 times g is 1. This gives us negative 2 plus 3 is 1 over 2 squared of 3. Now, I don't care what that number is. I don't care to rationalize it. I don't care anything. All I care about is, was this increasing or decreasing? So we found the slope, and 1 over 2 squared of 3 is a positive number. There's no negatives there. So we're going to say that's greater than 0. So we can say the graph, if you want to add a therefore, you can. But the graph of h of x is increasing, that's the what, at x equals negative 1, that's the where, because h prime of negative 1 is greater than 0, that's our y. So what, where, and why, if we have all three of those, we're going to get the justification right. Okay, next one. Again, that whole chain rule process. So we have basically the outside is a 2/3. So if we start with the outside, then whatever is the 2/3 is going to is going to be our box. So we're going to do p prime of x first. 2/3 times our box, which is 2f of x plus g of x to the negative 1/3 power times, now we're going to put in parentheses, 2f prime of x plus g prime of x, right? There's no product rule here because of the plus. There's no quotient rule, obviously, because there's no dividing. But the plus sign is kind of acting as our separator. So when we do the derivative of this box, that plus sign, where I'm going to cross out the 2/3, the plus sign is a separator. So we just do the derivative of the left, 2f prime, the derivative of the right, g prime. Now we can just plug in. So p prime of 0 equals 2/3. Now I'm going to just leave this as a negative 1/3 for now, and we can deal with it once we plug it in. So f of 0, right? F of 0 is negative 1, and g of 0 was negative 2. So 2 times negative 1, and then plus negative 2, or minus 2, however we want to write that, to the negative 1/3 power, times 2, now we need the f prime and the g prime. So f prime is 2, g prime is negative 3. So 2 times negative 2, positive 2. 2 times 2, right? And then plus negative 3. So this gives us 2/3 times negative 2 minus 2 is negative 4 to the negative 1/3 power times 2 times 2 is 4, and then 4 minus 3 gives us 1. So this is 2/3 times 1, so times negative 4 to the 1/3 power. And that's kind of a fine answer, but now let's just think about what happens to that. Is that becomes 2 over 3 times negative 4 to the 1/3 power, right? We're going to make that, this was a negative in there, negative 1/3 power. We're going to make that negative exponent go to the bottom. And then now we can say 2 over 3 cube root of negative 4. Right? Because 1/3 power is a cube root. So, I mean, this answer would have worked too, but I like to get into radical form. We cannot take the cube root of 4, right? We could take the cube root of 8. Now, on a multiple choice, you might see them actually take out the negative, which you can do. Because what happens is, like, right, the cube root of negative 8 is negative 2. But with, like, the cube root of negative 4, you can just take it out and make it negative cube root of 4. So they might do this, maybe. But I would never, try to ask you guys to do that on a homework. Just kind of recognize it on an AP exam. So next one, 15, and I think this is the last one for this homework. Find the equation of the normal line to the graph of h of x equals tangent of 3x. So the 3x is going to be boxed. This is a pretty simple chain rule. x1 is pi over 12, but a lot of us struggle on these because of not having our sine, cosine, tangent, our trig tables memorized. So to get the y1, we're going to just plug in pi over 12. That's tangent of 3 pi over 12, which is tangent of pi over 4. And the tangent of pi over 4 is a really easy one. It's just 1. Okay. So next, now we're going to take the derivative first, and then we can plug in to get our slope. So the outside is the tangent. So tangent of, we already boxed it. So the derivative of tangent is secant squared of our box, and times the derivative of 3x is 3. Now, on a homework assignment, like, if you were stopping here, we would just write it like this. On a multiple choice, it's going to be written like that. But if we're plugging it in, I always recommend writing it back this way. Right? Now, make sure you don't square the 3. Right? The 3 is not getting squared. Only the secant is getting squared. And the reason I like writing it this way is that's a lot easier to kind of think and visualize in our heads. So h prime of pi over 12 is 3 times the secant. Now, pi over 12 times 3 we already acknowledged was pi over 4 squared. Now, what is the secant of pi over 4? Well, secant is 1 over cosine. So in order to do that, we need to know what is the cosine of pi over 4. And the cosine of pi over 4 is square root of 2 over 2. So for secant, we always just flip that. So this is going to become 3 times 2 over square root of 2 squared. Now, you square both the top and the bottom. So this becomes 3 times 4 over 2. Right? Square root of 2 squared goes to the square root of 4, which is 2. Or you can just cancel out the square root and the square root. So that becomes 3 times 2, which becomes 6. So we end up with y minus 1 equals 6 times x minus pi over 12. All right, hope this helped. Email me if you guys have any questions, and I will see you guys in class tomorrow.